Then I think some other things that are important to know here is that if you run a single request, it will never be as fast as on NDB. And any ideas why? Well,
two-phase commit, you need
yeah.
to write 2 times.
Yeah, exactly. Yeah. And also the network latency, because you're typically separated in a MySQL server and the data nodes on different networks, right? So it will always be a little bit slower on an individual. Move on to the next slide. So if you want to migrate data into NDB Cluster, so I would first and foremost say like this. So if you're thinking about migrating a database that you're running now on NDB, I think I wouldn't advise for it, right? If you're going to migrate from, unless you have, it's a write-intensive application on NDB, the queries are reasonably simple, and so on, then it could be a good fit. But if you are taking an arbitrary web app that sits and runs on NDB very beautiful and nicely, and you want to have high availability on that, well, use a master-slave setup or use Galera. It will give you far less headaches than trying to migrate it into MySQL Cluster, to be honest. And anyways, if you do have some existing data that you want to migrate, you have to first, recommend you to dump the schema, only the schema. Then you dump the routines and views as well, so you can run them on all the different MySQL servers that you have connected to data nodes. And then you finally dump the data. And in here, I think the trick is to dump the data so that you dump it so you have either one file per database if you have many databases, or one file per table if you have many tables. And then you should load them in parallel on a couple of MySQL servers that you have connected. Because I'm sure that you have had problems, I know many people that have problems with Galera even to load in data. So they have dumped out a data set from a normal MySQL server that they had and want to load it in. And it bars before, because Galera in version 3.0 and 2.0, and it seems to be now that they have a better strategy for it in 4.0, has been quite weak with large transactions. And when you have an extended insert, you have multi-row insert, it can be quite a huge blob of information to write in. You can hit some of the Galera limitations. The node is off for, the nodes receiving the writes that they will be stalling for a period of time, they will lose network, all the different things can happen. And it's a little bit similar here, that you also have a limitation in MySQL Cluster, how many operations that you can do concurrently on one data node. So usually this is something set to 100,000, which might be a little bit too little, but it means that 100,000 concurrent operations can run. It's not 100,000 operations per second, but it's the concurrent operations that you can run. And if you exceed that, you will get an error back to your application saying, hey, I'm out of operations, I can't start this update or insert or whatever it is. Okay, let's go into some other things that are important to look at when you're deploying and running a MySQL cluster. You must make sure that you have disabled NUMA disabled essentially, because it's not working well with the NUMA optimizations, and I think most databases are not working that great with NUMA enabled. Set swappiness equal 1 is a good practice as well. It's a server you run, it's not a desktop application. And then it's you also have the possibility to the actual data node. Because internally in the data node, I was saying that there is a transaction coordinator, and then there are also some other components inside the data node. And you can schedule, and each of these components are running in their own separate thread. And you can place this thread on a given core. And it's a bit important how you place it, right? Because on some hardware, on some operating systems, you know, the operating system will do interrupts on a particular CPU or a particular core, and you typically want to avoid that, right? Because if you are running your most busy thread, bind it to the same core that is receiving the network interrupts, then you know it gets interrupted all the time, and you will have unnecessary crappy performance. So you can decide a couple of things in NDB in the data node. And then one first thing you can decide is how many transaction coordinators should actually each data node have. And the transaction coordinator is the front end to the transaction. And the transaction coordinator is then talking to one thing that's called local data manager. And that's another thing that you can decide on how many of those you should have. And typically if you have applications that are using range scans or large updates on ranges, then you typically need to have more of these local data managers. If you are more of a primary key based setup, then you can choose to have more transaction coordinator. And if you don't really know, then a good rule of thumb is one transaction for each 4 of the data nodes. And if you, for example, have a very powerful machine, then you would have, probably about 16 these data managers, which are the ones that are actually storing the data, and 4 of these transaction coordinators. That would be a good setup. I'll skip that slide, but and then there is a parameter called max number of execution threads that basically gives you a matrix of how many internal components you will get inside the data node. So if you set it to 8, you would have 4 these local data manager threads and 1 transaction coordinator. If you set it to 24, you will get something else, right? So that is the layout. But you also have the complete freedom and possibility to fine-tune this yourself with a parameter called the thread config. Yeah. You should also make sure that you benchmark your system as well. But you should also enable hyper-threading. That gives a bit more performance. And then also, it's not super trivial to understand where some of the threads are actually running on which core. But there is one file called the out file, which is the NDB out.log, which is stored in the data directory of the data node, which will contain this information. So if you go in and run top, you can see that one perhaps of these data node processes that are represented in top or htop or whatever will be running at 100%, right? And you have some log. Then you might have a little bottleneck there, right? And you might want then, it's probably the transaction coordinator if it's only one. And then you probably would like to make sure that you change the configuration so you have 2 transaction coordinators. And then you might see some other threads that are running on 100%, and then perhaps you need to increase the number of local data managers. Or you need to add more data nodes. There's another thing that is very important to talk about, to tune, and that's I think that's the most important parameter to tune in the entire NDB cluster, and it's the read log. The read log is specified by 2 parameters. One is called fragment log file size, which decides on disk how big, well, one read log file should be. And then how many, basically, of them that you want to have. And you multiply 4 to 6 times the amount of data memory you have in megabyte, divided by 4 times this number, and you get a good sized read log. It's not, all the parameters in NDB cluster are not exactly super clear. It's Swedish people that have written the software, so some of the names are or naming conventions might not be, you know, the most suitable all the time. No. Anyways, they're very long parameters. And if you're using disk-based data, then there's a very important thing to set up a shared global memory area that are quite big, and that you are when you're creating a log file group for the disk data tables, that you are setting a big undo buffer size from the beginning, because it's impossible to resize it afterwards without having to, you know, drop the table spaces, drop the log file group, and then recreate, and then you have, and you can also make sure that you are, you know, running that you have a same environment. If you see that you have major page faults, this column here, if it's, you know, increasing, that means that, you know, you are using it wrongly. Probably over-committing resources on the data node, right? So that you have more threads than you have cores, so they are competing, they have to be paged out, paged in, and so on, right? And that's expensive. Yeah, I think we can go through skip these things. You know, these are a bit things that are well, then, you know, how do you, you know, figure out, you know, if you have query problems and so on and so on? You do exactly as you would do in MySQL, right? You would have some kind of monitoring. You would use the slow query log. You would use the performance schema. You can use whatever, right, to understand if you have what are your top queries, which ones are slow. And naturally, you need to improve those queries. So it's nothing different at all compared to